As x varies over the real numbers, the largest value taken by the function 4 sine squared x plus 4 cos x plus 1 squared equals one of these given options. Okay, so we want to find the maximum value of this. First thing that comes to mind is, given that the whole thing is squared, this means we either want to find the maximum or the minimum of the thing on the inside, and then just compare those. Although the thing on the inside, maybe, I mean, it's almost certainly going to be, we're going to be looking for the maximum positive value because of the, because we have plus 1 at the end. So that's my first thought. But yeah, if we just go ahead and both maximize and minimize the thing inside, and if the minimum happens to be negative, that's the thing that'll be key. Probably won't be. And then to go ahead and figure those things out, maybe we just take some derivatives. Maybe we can simplify some expressions using trigonometric identities. I'm not completely sure. The people who watch my channel a lot know that I never have these trig identities memorized because I'm not writing these tests or preparing for these tests for real. So I think what'll happen if I take derivatives here? That might end up being a bit of a mess, right? I'm just going to go ahead with that, see what happens, and we'll backtrack if I think things are getting too complicated. Okay, so this is what I get when I take a derivative of the thing inside and set it equal to 0. We have either of these two things has to be equal to 0. So what is this saying? This is saying cosine of x equals 0, or sine of x is equal to 1 over 2. So what are my solutions to this? Okay, so cosine x equals 0. This says that x is equal to pi over 2 plus some multiple of pi. K can be any integer, is that correct? I think so. And sine x equals 1 over 2 says that x is equal to pi over 3. So we have 3 sets of solutions here, right? These are the ones which make cosine equal to 0. It's literally just all the roots of cosine. These are the values where sine x is equal to 1 over 2, where sine x is on the way up. And these are the ones where sine x is 1 over 2, where sine x is on the way down. I think I did that all correctly. I would want to, if I wanted to be very confident, I would plot the functions, draw some triangles, and things like that. Okay, so that's the first thing, is we found all the places where the derivative of this function is equal to 0. Well, the derivative, sorry, we found all the places where the derivative of this function is equal to 0. This is not exactly the function that we're maximizing here, right? Because the whole thing was squared. But yeah, we only need to worry about the minimum maximum of the thing that's on the inside. Okay, so what are the values of these things? Oh, you know what? I probably didn't actually need to solve for x here, because taking a derivative and setting it to 0 tells me, oh wait, maybe I do, because I need, if cosine x is equal to 0, I still need to know what the value of sine squared x is. Okay, so let's start with this one. When x is equal to pi over 2 plus k pi, okay, we know that cosine x is 0, so when I substitute x in there, that term goes away. At these value of x, what is sine x? So when k is odd, sorry, when k is even, sine x is 1. And when k is odd, sine x is negative 1. But in either case, this gives us 4 plus 1, which is 5. Okay, so we'll keep that in mind. We'll come back to that later. Now let's look at this expression. Okay, for that value of x, we know sine x is equal to 1/2. So sine squared x is 1/4. So this is 1 plus 4 cosine x plus 1. Okay, and at these values of x, what is cosine? Now I'm actually going to quickly draw a triangle. Yeah, no, okay, I think I'm all right. Okay, so cosine pi over 3 is root 3 over 2. Okay, and for the other one here, so I believe the cosine of these values, I believe, will just be negative. Negative root 3 over 2. Okay, so what we need to do now is take each of these numbers, each of those. These are going to be all the maxima and minima. In fact, we probably don't need this one, right? Because this one is going to be greater in absolute value. So we're maximizing, right? Yeah, the largest value. Okay. So then the question is, which of these two numbers is greater? I believe it's this one, right? Because, is it? Yeah, root 3 is greater than 1.5. If this was 1.5, then this whole thing would be equal to 5. But it's not, it's greater than 1.5, so this is bigger than 5. Meaning we need to take this number and square it, and that'll be the maximum of our function. Okay, again, I hope this is one of the options that's given. It's not. Excellent. So what have I done wrong? Oh, goodness. I computed the derivative incorrectly here. So right from the get-go, I had everything. This mistake obviously carried through everywhere. So I'm going to go through the whole thing again. I'm not going to make as much commentary on what I'm doing because I'm going to repeat. I'm going to do the exact same process, but hopefully with the correct expressions this time. Okay. This time I get that the maximum is 36, which is one of the options that's given. Again, I just went through the more or less the exact same process as I did before, except with the correct expression for the derivative. Yeah, there isn't too much more to say here other than, make sure your initial computations are correct. Otherwise, you end up wasting a lot of time. Thanks for watching.